Hi friends, welcome back to our YouTube channel. Today we have to discuss about C program for sum of individual digits of a given number using a recursion. It is one of the most important program that can be commonly asked in academic examinations and campus interview point of view. First, I am explaining the logic with example. After that, we can go for the implementation in the system. First of all, the given number n is equal to 1234. What are the individual digits of this number? 1, 2, 3, 4. Now, we have to find out these sum of these individual digits, that is 1 plus 2 plus 3 plus 4, that is equal to 10. Okay, so this is the simple example for sum of individual digits of a given number. First, we have to find out the individual digits of a given number. After that, we have to find the sum of those individual digits. Then we are getting the result 10. Okay. Now this entire program can be written using a recursion. So that we have to write the recursive function. Here the return type is int. The function name is sum of digits. This function can take one parameter, that parameter is n. Within this variable n, we are storing the number 1234. Its data type is integer. Within the body of this function, we have to write if n value equal to 0. So then return a 0. Suppose if n value is not equal to 0, so then here we have to write a return n modulus operator 10 plus sum of digits n divided by 10. Okay, so here the function name is sum of digits. The same function can be called within the body of this function sum of digits. Then it can be called as a recursion. A recursion is nothing but a function called by itself. Here the function name is a sum of digits. It can be called within the body of this function again. Then it can be called as a recursion. This function is called as a recursive function. Okay. Now, in the main program, we have to write void main. I am taking int n is equal to 1234. Now I am taking one more variable, that is the result variable. In that result variable, we have to store the sum of the individual digits of a given number, that is 10. So here we are calling the function result is equal to sum of digits of n. This is called as the calling function. So once we are getting the result, that result is stored in the variable called result variable. Now we have to print the resultant value. So this is the simple logic. Okay. Now I am explaining step by step. Okay. Every C program execution starts with main function. Okay. The main function does not return anything, so that we have to write void before the main function. Void is an empty data type. Within the main function, I am declaring integer variable n. It can store the value 1234. Now I am declaring another integer variable, that is a result variable. Its data type is integer. Okay. Now we are calling the calling function in the main program. This is the calling function, sum of digits. It can take one parameter, that is n. Whenever we are calling this function in the main program, the program control can be transferred from calling function to called function. So this is the calling function and this is the called function. Okay. So whatever the parameter that we are passing in within the function, that is called as actual parameter. So whatever the parameter that we are passed in the called function, that parameter is called as formal parameter. Now actual parameter value n is equal to 1234. That can be copied into the formal parameter when we are transferring the program control from calling function to called function. Now here the n value is 1234. Okay. This is the called function name, sum of digits. Its return type is integer. Okay. So within this called function, suppose if n equal to 0, here what is n value? 1234. 1234 equal to 0, that is false. Here if this condition is false, then the control goes to the else block. Okay, within the else block, return, so n modulus operator 10. Here now I am in iteration 1. Iteration 1. Here return n modulus operator 10. I am writing here return n modulus operator 10 means 1234 is the n value. 1234 modulus operator 10 plus sum of digits 1234 divided by 10. Okay. So what is the value we are getting? So return 1234 modulus operator 10. So that is nothing but 1234 can be divided with 10. 10 123s, that is 1230. So what is the remainder value we are getting? That is 4. The modulus operator always returns the remainder value. So what value we are getting? That is 4 we are getting. Okay. 4 plus sum of digits. Sum of digits 1234 divided by 10. So it returns the quotient value. So here division operator always returns the quotient value. Modulus operator always returns the remainder value. So please keep in this point in mind. Okay. Division operator always returns the quotient value. Modulus operator always returns the remainder value. Here what is the value we are getting? So that is 123. Okay. Now again we are calling this function sum of digits of 123. Okay. So this is iteration 2. Iteration 2. Okay. Sum of digits of 123. Now n value is 123. Okay. Now within the body, if 123 equal to 0, So that is false. So then control goes to the else block. Within the else block, so here return 123 modulus operator 10. So here 123 modulus operator 10 means 123 is divided with 10. We are getting 120. Remainder is 3. Okay. So here modulus operator always returns the remainder value. 3 plus sum of digits of 123 by 10. 123 by 10. Okay. Here I am writing 123 modulus operator 10. So what is the result we are getting? Return here 123 modulus operator 10 value is 3. 3 plus sum of digits of quotient value is 12. This value returns the quotient value, that is 12. Okay. Now n value is 12. Again it can call the recursive function. So now n value becomes 10. So this is iteration 3. Iteration 3. Okay. Now, so here n value is 12 is copied into this one. So int sum of digits of 12. The control goes to the body of the recursive function. If 12 equal to 0, that is false, then the control goes to the else block. This statement is executed. So that is return n modulus operator 10, that is 12 modulus operator 10 plus sum of digits of 12 divided by 10. Okay. So 12 divided by 10. 10 ones 10, remainder 2. Okay. So here what is the result we are getting? 12 modulus operator 10 value is 2. So this is 2 plus sum of digits of 12 divided by 10 returns this value, that is 1. Okay. So again we are getting n value as 1. Again it calls the recursive function. Again the control goes to this place to this place. Now this n value is copied into here. Okay. Now we are getting iteration 4. Iteration 4. Okay. In the iteration 4, n value is 1. The control goes to the body of the recursive function. If 1 equal to 0, that is false. Then the control goes to the else block. Within the else block, this statement is executed. So here return n value is 1. That means 1 modulus operator 10 plus sum of digits of 1 divided by 10. Okay. So now 1 is divided with 10, 10, 0, 0, remainder 1. Okay. So this value is return 1 plus sum of digits of, here this value becomes 0. Quotient value is 0. Okay. So again it calls the recursive function sum of digits. Now n value is 0. So now n value is 0 is copied into n. Int sum of digits of int n value is 0. Then the control goes to the body of the recursive function. If n value 0, 0 equal to 0, condition true, the control goes to the body of the if block, return 0. Okay. Now this entire value becomes 0. So now if n value is 0, this value becomes 0. Return 1 plus 0, so that is equal to 1. Return 1. Okay. Now this value can be sent to this place. Okay. Here this entire value is 1. So here 1. So 2 plus 1, so that is equal to 3. Okay. This value can be sent to the above iteration. So this value becomes 3. So now this is 3 plus 3, that is equal to 6. Okay. Now this value is sent to the above iteration. Okay. So now this value becomes 6. 6. So 6 plus 4, that is equal to 10. Okay. So that means once we are getting this value, sum of digits of 0, so this value is added to this value. So then we are getting 1. 1 plus 0, that is 1. This 1 can be returned to the previous iteration. So here 1, this value is 2 plus this value is coming from the iteration 4. So 2 plus 1, that is equal to 3. This value can be sent to the iteration 2 at this place. So this value is 3 and this value becomes this value. So 3 plus 3, that is equal to 6. Again, this value can be sent to the iteration 1. So sum of digits of this value is 6. Here this value is 4. 4 plus 6, that is equal to 10. Okay. So finally, from this entire function, it can result what is the value? That is 10. 10 can be sent to this place. Okay. So 10 value can be assigned to the variable, that is the result on the left hand side. So then the result variable store the value 10. That 10 value can be printed. Okay. So in this way the recursion tree working. Okay, this can be represented with a recursion tree. Okay. Now we can go for the implementation of sum of digits of a given number using a recursion. Hash include stdio.h. This is called as standard input output header file. It contains the printf and scanf functions. Hash include conio.h. This is console input output header file. It contains conio, clr, scr. We are already discussed the logic of sum of digits of a given number using a recursion. Now we can implement the logic in C programming. So this is the C program. So hash include stdio.h. This is a standard input output header file. Hash include conio.h. This is console input output header file. These first two lines are called as header files. We have to include these header files to our program. Next, this is function prototype. We can tell to the compiler this is the function that we are used in the program. Int sum of digits of int. So return type is int. Sum of digits is the function name. It can take only one parameter, that is integer parameter. Next one, void main. Every C program execution starts with main function. main function does not return anything, so that we have to write void before the main function. Next, I am declaring two integer variables. First one is n and the second one is result. In the variable n, we are storing the number that are read from the keyboard. For that number, we have to find the sum of digits of a given number. In the result, so whatever the number that are read from the keyboard, so we have to find out the sum of digits of a given number. Whatever the result we are getting, that result is stored in the variable called result. CLR, it clears the output screen. This function is available in conio.h header file, so that we have to include that header file to our program. Next one, printf enter the given number. So that number can be read from the keyboard by using scanf function. That number is stored in variable n. Next one, result is equal to sum of digits of n. So here this is called as calling function, sum of digits of n. Whenever a function is calling in the main program, the control transferred from calling function to called function. Called function is available outside the main function. So now the program control can be transferred from 11th line to 15th line. Okay, so here called function, return type is int, function name is a sum of digits. It can take one parameter, that is int n. Okay, here whatever the n value we are passing in the main program of calling function, that value is copied into the formal parameter n. Okay, so here this n is called as actual parameter and this n is called as formal parameter. The value stored in actual parameter n is copied into formal parameter n. Now we have to check if n value is equal to 0. If this condition is true, so the statement within the if block is executed, that is return 0. 0 value is written. Suppose if this condition is false, now this statement is executed. Return n modulus operator 10 plus sum of digits of n by 10. Okay. So here this function is called as a recursive function because here called function name is also sum of digits. Within the called function, again same function name is called, then it can be called as a recursive function. The process of calling the same function name within the body as a statement, then it can be called as a recursion. Okay, so first this step is executed again, so it can call the called function. Okay, so again and again calling the same function until the condition is false. If this condition is false, a recursion step is stopped and return the result to the main program. Okay, so that is a transfer from called function to calling function. So whatever the result we are getting, that result is stored in the variable called result. So after that, printf sum of digits of percentage d is nothing but n, percentage d is nothing but result. Okay, sum of digits of given number n is whatever the result that is stored in result variable, that is printed. After that, get ch. Get ch is also there in conio.h header file, so that we have to include that header file to our program. So how we are getting the result, that is already discussed in the logic. Please refer the logic. Okay. First we have to save this program. Next, we have to compile the program by using a command called Alt plus F9. We are getting 0 errors and 0 warnings. Next, we have to run the program by using a command called Control plus F9. Enter the given number. I am giving 1234. See this one. Sum of digits of 1234 is 10. That means 1 plus 2 plus 3 plus 4, that is equal to 10. Next, once again we are compiling the program. We are running the program. I am giving the number 4567. So sum of digits of 4567 is 22. Okay, so this is the simple program for sum of digits of a given number using a recursion. I hope all of you understanding this program and logic. If you have any doubts, please put your doubts in the comment section. I will try to clarify your doubts. If you really like this video, please click on the like button and click on the bell icon to get the future updates in my YouTube channel. After subscribing my YouTube channel, Divvela Srinivasa. Don't forget to subscribe my YouTube channel. If you really like this video, please forward this video to your friends and classmates. Thank you. Thank you one and all for watching this video.